Let me just check if I'm live. Okay, I'm just doing last eye tests to see if everything is set up properly, and it is. And as I promised, today, we are gonna do an example from the book, and the example says the following: implement. So what are we gonna implement? Batch gradient. So implement batch gradient descent with early stopping for softmax regression. With early stopping for softmax regression. For softmax regression without using scikit-learn. Using scikit-learn only NumPy. And then it says use it on a classification task such as the iris dataset. Use it on the iris dataset. Okay, so this is the question, and for anyone watching, I only started learning about machine learning maybe a month ago, so most of these concepts are extremely foreign to me. And the extremely foreign concepts are, I mean, not extremely foreign. Why am I saying extremely foreign? I just want to mention the things that are still a bit unclear. Batch gradient descent, sorry. Early stopping, I think I skipped this subchapter from the book completely on early stopping. Softmax regression without using scikit-learn. I know what scikit-learn is. It's is this Python library. So I don't this didn't sound very confident, but I work with scikit-learn basically, so we don't need to implement this using scikit-learn. We need to implement it using only NumPy. Use it on the iris dataset. So let's start with some of these concepts. Let's start with some of these concepts. Just a moment. I keep getting notifications. I don't want them to interrupt me or the stream. So what's the first thing? batch gradient descent. What is it? What is it? How is it implemented? Okay, just a second. Okay, so let's start with the batch gradient descent here. I'm just gonna select a new color. So batch gradient descent, I remember it from the book, but I don't seem to recall much of it. I know that it's one of the basics, one of the foundational concepts. And basically here it says batch gradient descent is an algorithm that updates model parameters by using all training data at once to compute the gradient of the cost function. It's called batch because it processes the entire batch of data before making a weight update. This doesn't mean, hasn't made it a lot clearer. Wait. Bum. In this era of deep learning, where machines have already surpassed human intelligence, it's fascinating to see how these machines are learning just by looking at examples. When they say we are training the model, gradient descent behind the scenes who trains it. First of all, gradient descent is a first-order iterative optimization algorithm for finding the minimum of a function. This seems a little complicated. Great. Who is this guy? Sushant? Sushant. I'm really sorry if I butchered the name. This is the greatest mentality to have. Explain it. So, gradient descent is a first-order iterative optimization algorithm for finding the minimum of a function. The goal of the gradient descent is to minimize a given function, which in our case is the loss function of the neural network. Okay. To achieve this goal, it performs two steps iteratively. It computes the slope, the gradient, that is the first order derivative of the function at the current point. And then, it moves in the opposite direction of the slope. Move in the opposite direction of the slope increase from the current point by computed amount. So this is the slope. We are looking at the global minimum. So if the slope is here, we calculate the gradient, and then based on our calculations, we move the slope point down to the incrementally to the minimum cost. The idea is to pass the training set through the hidden layers of the neural network and then update the parameters of the layers by computing the gradient using the training samples from the training dataset. Yeah, it's the same example. I remember this example. There is a man at the top of the valley and he wants to get to the bottom of the valley. So he goes down the slope. He decides his next position based on his current position and stops when he gets to the bottom of the valley, which was his goal. So that's gradient descent. Now, there are two types of gradient descent. There is batch gradient descent and stochastic gradient descent. All the training data is taken into consideration to take a single step. Yes, so stochastic takes only random Only a couple of random data sets. Yeah, okay, okay, okay. So we need to implement some math as well for this. I'll need to implement some math for this as well. Let me go back to the example. Implement batch gradient descent with early stopping for softmax regression without using scikit-learn, use only NumPy, and use it on the iris dataset. So this is the batch gradient descent. Where's the math behind batch gradient descent? Where's the math? Batch gradient descent math. How is this working? Wait. Wait. Mathematics behind batch gradient descent. No, this is too much. This is too much math. Why don't you why don't you properly write these math examples? Don't you use like Markdown or LaTeX or something like that? Okay, so let's see we are using linear regression. And then we have a cost function when we have our design metrics, when we have a vector parameters, and we have our label vectors. You know what the problem is? I can explain this. Look at this. Wait. I know how this works. So I can create here a simple data set like X. It's an NumPy array. I won't write this, but it's gonna contain 1, 2, 3, and let's say 4. And it's a shape of 4, 1. Basically, we have 1 row and 4 columns. And then I have the same thing for the solutions. It's gonna be 3, let's say 5, 7, and 9. And let's say we want to predict the simplest possible thing, and that's a line here. So what we need to do now is for the because we also need to add we need to add just a second, a bias as well. So in order to add a bias, we are going to add a 1 to the beginning of the X matrix. So it's going to be 1, 1, and the other guy is going to be 1, 2, 1, 3, and 1, 4. Okay. Because this is the bias, this is our X. Because we need the bias every time for some reason. I don't know why. I don't know. Okay, and what am I doing then? What am I doing then? Batch gradient descent loop. Yeah, I need to add a learning rate, how fast the line is gonna move. I have the number of iterations. And then I'm calculating the gradients. But that's the problem. I need to know how the math behind the gradients works. Wait. Wait. Let's do another example. Okay. Batch gradient descent is helping me finding the best line that fits my data. Okay. The best line that fits some data. Again, I'm going even more basic because I want to make sure I understand this. So I have y, and I go back to the theta, it's gonna be theta 0 plus theta 1 x, where theta 0 is the intercept and theta 1 is the slope. This is where the line crosses the y-axis. This is how steep the line is. So our job is to find the best these and these. And there's the cost function, and that's the mean squared error one. Mean squared error, which is, where's the formula for this? Formula, I think it's this one. So we have the number of data points, we have observed values, we have predicted values. So we subtract either the observes from the predicted or vice versa. I think in the end you get the same because you're squaring it either way, and then you divide it by the number of data points here. And that's the formula. And then, right, so then we do something else. So after calculating the MSI, we update theta 0 and theta 1. But how do we update theta 0 and theta 1? All right, so we have a learning rate. Wait. Is there a formula for gradient descent formula? Batch, please show me. I just want to see the image. Is this it? I think this might be it. If someone is watching this, I have no idea what I'm doing. Is this it? What? So this is the batch gradient descent. What? So this is, okay, so this is the regular MSI, the regular mean squared error. I know this. And it says, so we just have a lambda learning rate, which is an additional property here. Okay, let's leave this and let's do a simple example by hand, and hopefully it's gonna amount to something. So if I have x to be 1 and 2, and I have y to be 3 and 5, so we have 2 points to solve, and I can start with theta 0 to be 0 and theta 1 to be 0 as well, and a learning rate of 0.1, and then I need to predict for each point y prim is going to be theta 0 plus theta 1 multiplied by 1. So this is 0. And theta 2 prim is going to be theta 0 plus theta 1 multiplied by, I mean, it's 0 again. Okay, and then I need to compute the errors for this. So these are my values that I got. And the values are 0 and 0. The values are 0 and 0. But my real values here are 3 and 5. Right? So I want to compute the errors now. And the errors will be, I'm going to have error 1 is going to be 3 minus 0, it's going to be 3, and I'm going to have another one, it's going to be error 2, which will be 5 minus 0 is going to be 5. And now, after I got errors, I need to compute the gradients here. And the gradients, if I'm not mistaken, I'm computing using this formula here. But do I? Is this the formula for gradient descent? Just a second. Gradient descent formula, batch gradient descent. Where's the mathematical formula behind this? Is this it? No, it's not. Batch gradient descent formula. Okay, so I calculated the error. I put these values here. So I assume the next step no, this is not it. What's the formula for batch gradient descent, man? Wait. Oops. Okay, this is the cost function. I need the batch gradient descent. Where's the formula for it? The mathematical formula. No, this is momentum. How can't I find this? The batch gradient descent. Man, it's the fucking Brave AI, which is shitty on its own. Like all of the search engine AIs are incredibly shitty. But if Brave AI gives me an answer that I couldn't find Googling, then search engines are done for. Using the entire dataset, the update rule for the parameters theta is given. So theta is theta minus n multiplied by, so what's theta is the learning rate, and yeah, of course it's still broken. Of course they're still broken. Why did I expect anything different? In the context of linear regression, the cost function Theta is typically the mean squared error MSI, and gradient is computed as this. Wait, let me go back here now. So I got the two errors. And now I need to calculate the gradients. Okay. So I'm most probably calculating the gradients using a formula. Minus 2 over m, the size of the set. And then I multiply it by the sum of yi minus yi prime. So this is gonna be then minus 2 over 2 because we have two elements in the set. And then I multiply it by the sum of this. And what's my first example here? What's my first example? Y minus y. So it's so it's the sum of yi minus yi. How? Okay. So I have only two elements. So what I'm gonna have is, because I have the sum of I think I know what's happening here. So the sum of y is 3 plus 5 because these are the y's, and the sum of y premise is 0 and 0. So I'm gonna have 0 and 0. And then I'm gonna have minus 8 for the first gradient. And for the second one, I'm doing the same thing. I'm gonna write the formula 2 over m, and I'm multiplying it again by the sum. It's gonna be 3 plus 5 minus 0 minus 0 plus 0 is gonna just be minus 8. But then I also add another thing here. What do I add here? I multiply it by, wait, this is a whole sum. How does this work? How does this work? So I sum this, but I also multiply. Okay, I know. So I have these two formulas here that I'm looking at, and I don't know if they are correct. I don't even know what they mean. But I think I have it now. So the x for, so again, I'm doing this. I'm having minus 2 over 2. The sum is, what is the sum? It's 3 plus 5 minus 0 plus 0, but I'm then multiplying this as well with the x times x on the I. It's going to be minus 1. These two will be 3 times x from its own row, from its own data set. Is going to be 3 plus 10. The other two are not important. It's minus 13. Is the book saying so as well? Yeah. Okay, so now I calculated the gradients. Now I need to update the params again. So I'm doing theta 0. Theta 0, the original one is 0, minus 0.1. This is the lambda. Multiplying it by minus 8. It's going to be 0 plus 0.8. The first one is going to be 0.8, and the theta 1 is going to be 0 minus 0.1 multiplied by minus 13 is going to be 1.3. And we update our line to be y 0.8 plus 0.3x. And this is the batch gradient descent. Explained to the simplest possible data set. Okay, where are we now? Here. This is the example. Implement batch gradient descent with early stopping. Okay. For softmax regression. What the hell is softmax regression? Oh, I hit my mic. I apologize. Wait, where's my code? Here. Implement batch gradient descent with. Alright. Let's start by loading the data. We'll just reuse the iris data set we used earlier. Okay, so we have iris data. And I get the values from the length of the petal and the width of the petal, and I also get the target values. So we will have our predictors. Most probably the predictor for x will be, let me just write this. So the predictor for x will be a tuple of numbers, and the predictor for y will be the label of the flower. Okay, so it's not a stringified label. It's a label. Okay, zeros, ones, and threes. So most probably zeros, ones, and twos. So most probably we are mapping these numbers to something else, to some labels maybe. Okay. So what else are we doing? We need to add the bias term for every instance. Okay. The easiest option to do this would be to use scikit's add dummy feature function, but the point of this exercise is to get a better understanding of the algorithms by implementing them manually. So here's one possible implementation. Okay, just a second. My question here is, why do we need to add the bias term for every instance? I'm trying to really understand this. Okay, why? So we have y theta 0 plus theta 1x. This is a linear model. This is a linear model. And why do we need a bias? Because without a bias, the model is forced to go through the origin 0, 0. Okay, so if I'm drawing a line on a system, if I only have theta 1 x, the line must go through the point 0, 0. Ah, all right. So if I only had theta 1 x y, if input is 0, output also must be 0. So if it's here 0, the line would go to the 0, 0 coordinate. So the bias gives the model flexibility to shift up or down. But why do we add the bias term to every instance? Because each prediction needs that shift. Okay, so we need to add it to every instance. So we need to add the bias. Why? No. No. Okay. We need to add the bias term for every instance. The easiest option to do this is to use add dummy feature, but because we only use NumPy here, this is the way how we can do this. Okay, this is the bias. Okay. The next step says the easiest option to split the dataset into a training set, a validation set, and a test set would be to use scikit-learn's train test split function. But because we want to do it manually, we need to do something else. So what is my idea of trying to do this? How would I do this? How would I do this? So what's the question? How to divide the dataset without scikit-learn, only using NumPy. One idea is what? So I can wait, but I can just divide them, right? So I'm gonna get a random seed. I'm gonna get a random seed. I'm gonna shuffle my indices, and then I'm gonna. Okay, what did they do here? So we have the test ratio, they have the validation ratio, and they have the total size, which is x with bias. So the test size is the total size times test ratio. Okay, so just calculating here the size of the test is gonna take 20% of the total size. Validation size, same thing, is gonna take another 20% from here. It's gonna take another 20% from here. What else do we have here? Down. And the train size is the total size minus test size minus validation size. Okay, will make sense. What's the next one? I swear to God, I wanted to do the same thing. So we get a random seed, then we randomly permutate it. The total size. No. Then we permutate the total size, and then because the indices will be the same if we use the same seed every time we run the app. And then I just pull, yeah, do the same thing. I pull, what's this? Ah, okay. So what do I get if I print random indices here? Yes, it's the random IDs. So here I have all the random IDs of the set. And what I'm doing is I'm taking this representation of a set, which is just an array with lots of numbers. And I'm saying, oh, okay, give me whatever train size is, 20%. Same thing here. Then I use xValid for validation. It does the same thing. It gets the random indices and okay, but it does something different here. It starts from the train size and it goes to the test size. Oh, sorry, I have a message. Hey, Subhansu. I don't think I can help you a lot. I'm also learning this stuff. I plan to switch careers. Oh, sorry, I need to get some water. I need to switch careers into as you said, the same thing, something data science adjacent or AI. So I'm also learning this. I don't think I can be of much help for you. But I'm working as a software engineer, so if you need any help with that, let me know. And I'm confused between doing DSA and data science with Python. Which should I go for? And if you can tell me the approach for it as well. But the approach for it is just study. Just the thing that people do wrong, and the thing that I'm doing wrong as well, is going to the next paragraph or phrase without understanding. You don't need to learn to remember or to learn it by heart, by understanding everything that is written above. I think that's the most important thing. Okay, so yeah, and what's the train size? Wait. Print train size. No, not train size. It needs to be train size. 90. Okay, and what's validation size? And what is then test size? Just a second, please. You're also doing data science. No, I'm a software engineer. I'm learning this because I'm also hoping to switch careers at one point in the future. This is a learning. Apologies. This is a learning stream. Okay, so the train size is 90. Okay, we are testing on 90 elements. We validate on 30 and we test on 30. Let me just do something else. Let me just take a look at this. Train size. Oh, what did you learn to be a software engineer? I went to a general um computer science, what's the name, curriculum. And also I think in a regular computer science curriculum you do all the stuff like all the basics. You do introductions to programming, you do advanced programming, data structures and algorithms. Basically even data science. We did data science and data mining and machine learning as well. Actually we had a course called AI. It's only one course. And then I think after 4 years you specialize in on your masters in what you specifically want. Then you can do, I don't know, specializations in data science. But we did a lot of everything, and as you can see here, I didn't remember machine learning very well. Okay. So what's the chain size? It's 90. So what's the length of? Okay, because it's gonna pick the first 90 elements. Then this guy is gonna pick it's gonna start from these and then it's gonna go back to test size, and here I'm just picking from the test size, right? What do you also do? Yeah, I have a job as a software engineer. Full time, baby. Do you also do your job? Yeah. It's a good job. Like you start doing these things uh, like different areas of a project, and you learn how the life cycle of a project works and architecturally how it works. And I mean, all the way to the basics. Once you start, whatever, changing the labels or colors on the buttons or creating API endpoints, it's a good and fulfilling. Can you guide me for the job placements and all, since I'll be in the final year soon? Man, just do internships. Just do internships. And projects. That's the only thing you can do. What people do wrong is that they try to over focus on the theoretical aspect. Like, you know, I don't know, bubble sort or deception sort. You know it in your hand, in your head, like how it works. But if you can't implement it, like you're more or less useless. Whatever you do, the practical, and experimental side is a lot more important than the theoretical. That's why I'm doing these example exercises here. I don't know. For example, look at this. Implement batch gradient descent with early stopping for softmax regression without using scikit-learn, Yoni, NumPy. Use it on a classification task such as the iris dataset. I understand half of these words, but I think it's a lot better to learn like this because you are learning from real life examples. This is something that you might get to work on your job, as a machine learning engineer. The same thing as, once you build your first tiny project for, no idea, let's say you get APIs from a weather, you get responses from a weather API, and it tells you in the morning if it's gonna fucking rain or something stupid like that. You might use it. Okay, I hope I answered your question. I need to go back to this. Okay, minus. Okay, I know what being. Okay, the targets are currently class indices 0, 1, or 2, but we need target class probabilities. Okay. So lead code is really good. Like, lead code is really good when they want to filter out the first couple, the junior applicants. Lead code is amazing. They're gonna give you 3-4 examples. You learn lead code. You do whatever. You throw the dice 10 times. What's the possibility of 6 appearing 2 times or something stupid like this, which is really good because it makes you think, and you are learning concepts like mathematical probability by using this, by solving lead code. But you need to have also projects on your own. Projects like, I don't know, what could a good project be, man? I don't know. If you like Pokemon, you can use Pokemon API and you can create your own Pokédex, for example. That's a really simple example. Also, regarding lead code, like lead code is only used for junior and maybe mid-year developers. If you make it through 5-10 years in the industry, no one is gonna ask you lead code anymore. I don't know, unless you go to Google or some other bullshit FANG company or something. You know, the kind of guy where you need to fight other guys to remain on the top. The rat race, the constant rat race. Just a moment. I got a message. No, I mean, Google is amazing, but Google and all of these top companies, like, they are nurturing this narrative of, I'm gonna squeeze you out as much as I can in order to see if you are good. And once you get employed, you are not doing any of the stuff I squeezed you out for. Like, you're gonna study 6 months to pass Google, and it's amazing. I would like to work in Google, man. Imagine I try out for Google and I pass all the steps, and then they say, okay, you said that this is a bullshit company, we can't accept you, man. I'm sorry, but yeah, they are squeezing you out dry because, again, they are the best in the best, but you are not doing anything different that you wouldn't do in a B tier level company. Only you are getting paid more, and it's on a wider level. Okay, let me go back to this. The targets are currently classing. Okay, we need target class probabilities to train the softmax. What the fuck is the softmax regression model, man? What is the softmax regression model? Okay, that's one question. Each instance will have target class probabilities equal to 0, 0. 0, 0, 4 classes except for the target class, which will have a probability of 1. In other words, okay. Okay, so softmax regression is just classifying something into one of 3 or more categories. So how does it work? Where's my tablet? How does it work? Okay. So softmax regression. So 3 or more categories. Okay. So I did this the last stream and I forgot all about this. So softmax answers the question instead of answering is this 5. If you remember the last chapter that we read, we solved an algorithm a model that answers is this 5 or not. Now softmax is gonna answer what, for example, what kind of flower is this? What kind of flower is this? And how does it work? How does it work? So if I give it an input x, I have an input x, and if I provide it to this factory that does softmax, I'm gonna get, depending on the amount of classes, I might get something like this: 0 0.7, 0 0.2, 0 0.1. Man, I'm just confused, man. Like, people are doing so many things, and every time I see someone is ahead of me, I always feel them. Man, me too, man. I think it's just something that is normal in the human nature. You know, you look at people you want to be, and you want to achieve the same amount of successes they have, but at the same time, you didn't have the same start as that person. You know, I don't think it's bad to wish what other people have, or to be in a place where other people are, but you have your own journey to make. And the thing is, as long as you keep on grinding, man, you're gonna make it. You know, but you need to start, and you need to do it. Do you know about the theory that you're gonna become an expert in something if you do it for uh 10,000 hours? So look at this calculator. Where's my calculator? Here. So it's like, if you so if you do something for 4 wait 10,000 hours divided by, I don't know, let's say you do something 2 hours a day, you study something 2 hours a day, so you're gonna need 5,000 days for this. So how much is this divided in years? Divided 5,000 divided by 365, so it's 13 years. You know, maybe you are only starting and someone here is halfway there, or someone does 4 hours a day while you do 2. You know, it's normal to I don't know. I think it's normal. I don't know why people say, "Oh, don't look at other people." I think it's normal to see what other people have achieved and you trying to emulate it. But you know, you don't need to be obsessed with it or demotivated. You need to be motivated to do things. Just do things, man. I don't know if it makes sense. Oh, sorry, I went on a tangent so much I even forgot what I want to do. So I hope this made sense. Okay. You give it an input text and it produces a probability distribution over all classes. So yeah, if I give this, it basically says, okay, it's 70% the first one, 20% the second one, and 10% the third one. And it always adds up to 1, like rolling a weighted die. Now, how does the math work for this? That's the most important thing. Everything else. So wait, let's go back here. But we need target class probabilities to train to softmax regression model. Each instance will have target class probabilities equal to 0, 0 for all classes except for the target class, which will always have a probability of 1. In other words, the vector of class probabilities for any given instance is a one-hot vector. Let's write a small function to convert the vector of class indices into a matrix. Wait, what have I done here? How do I close it? How do I close it? Okay. This creates an end-to-end match. What? Thank you, brother. For example, now I'm stressed as fuck because I don't like this shit. Stresses me out so much. But you know, if I do this every day for the next month, start of next month, I'm gonna understand this more than I did right now. Thanks for the subreddit. Oh shit, is my internet down? Why is it so slow? What's my speed? Speed test.net. No, my internet is okay. So, what is this meaning? What is this doing? I also okay. There is a mention of a one hot vector here, and a one hot vector is a vector that, depending on the amount of classes it has, in our case we have 3 because we have 0 0.7, 0 0.2, and 0 0.1. Depending on the amount of classes it says, we can do something like this. It's 1, 0, 0, which means that class 1 is the one correct. The second way is 0, 1, 0, and the third one is 0, 0, 1. So this is just a way to represent one hot vector. So if we have something like this now, if we have something like this, it's y, it's 0, it's 2, and then it's 1. So if I have something like this, I need to turn it into a one hot vector somehow. What do I need to do? Okay, so I need to turn it into this form. So now I need to create. Now I need to create. Oh man, this is so stressful. This is so stressful. This is so stressful. I mean, it's not as stressful as, I don't know, going to a war or jumping from a cliff, but I hate these books. I hate textbooks. I hate them. I hate them with a passion. It's overly complicating stuff. I can ask ChatGPT to simplify all of this, and I'm gonna get something that's easier to understand. Each instance will have target class probability is equal to 0. Okay, the target class will have a probability of 1. I'm gonna create a one hot vector. I understand this. Let's write a small function to convert the vector of class indices. Oh fuck, I'm an idiot. Oh man, oh man, oh man, oh man. I'm an idiot. Man, I'm an idiot. So basically, let's say I have these, how could I call this? These are the true values, I think. What's the more proper name to name this? Am I gonna call them true values or target classes? I can call these target classes. Okay, so these are the target classes right here. So I need to convert them into an array of one hot vectors. These are one hot vectors. So what I need to do is the first one. We know that target class is 0, so it's the first flower. So if I convert it to here, I'm picking up this one hot vector. So gonna be 1 0 0. Now the second one, I know that it's the second, but we are indexing from 0 and because it's the second one is gonna be 1 2 3. It's or 0 1 2. It's this one, so it's gonna be 0 0 1. And the last one will be 0 1 0. And this is a way to convert a value to one hot vector using only numpy. And but how is this working now? Let's see. I have numpy once. How is this working? How is this working? Basically, this line of code is converting my list of class labels here. Oh, I can also move my tablet from my computer. I didn't know this. So I need to convert this into this. But how? So first of all, numpy once y max plus 1. Let's do this line first. Numpy once y dot max plus 1. So what is this doing? This will create a vector of ones, one for each possible class. So if I have a y, oops, if I have a y, as I said, that consists of 0, 2, and 1, what is y max? Y max is 2, right? And y max plus 1 is 3, which means that we have 3 possible classes. So if I do numpy, numpy once, and here we will have 3. What am I gonna do? I'm gonna just create a new numpy array. And the new numpy array will have 1, 1, and 1 here. And then we also have numpy diagonals, and I'm taking this as an input. And what numpy diagonal does, it creates a diagonal matrix from this array. So I will have here 1 0 0 0 1 0 0 0 1. Okay. And now we have an identity matrix where each row is a one hot vector for a class. So what else do we have here? Why? Yeah. Okay, I understand why I have why I did all of this, but what is the why here doing? So this part is advanced NumPy indexing. It selects rows from the matrix based on the values in Y. Okay. It selects rows from the matrix based on the values in Y. Okay, so if I have this NumPy array right here, and I do all of this, I do NumPy once, NumPy diagonal, and then I also index it by Y. What am I getting? Ah, okay. I understand it now. So we have this. This is now a list of one hot vectors. And now when I index it from here, I'm gonna pick 0 is this, 2 is this, 1 is this, and I will get a result here. Let me go back here. So we are training on the first 10 elements. And what are we gonna get? We're gonna get a list of one hot matrices, and the first element will be 0, 1, 0. Oops, the second one will be 1, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 0, 1, 0, 0. So basically we are just, with this method, I'm just converting my data class vector, my just a second, my class label vector. I'm converting it to a matrix of one hot vectors. Okay, looks good. So let's create a target class probabilities matrix for the training set and the test set. Let's create a target class probabilities. For the training set and the test set. So what are you doing here? Okay. For the training set and the test set. And I just did the same thing now. So I have train, Y train one hot. If I print, I mean, I don't need to print any of these guys, but print Y train one hot, we're gonna have a matrix of one hot vectors. Yes, and the other two as well. We'll have the same structure, maybe not the same elements in them, but the same structure. What are we doing then? Let's scale the inputs. We compute the mean and standard deviation of each feature on the training set, except for the bias feature. Then we center and scale each feature in the training set, the validation set, and the test set. What? Why? Okay, here we are picking, I think, okay, we are doing feature scaling, right? Yeah, we are doing feature scaling. But why are we doing this? Okay, we calculate the mean, we calculate the standard deviation, and then we standardize the values in training, validation, and test sets. And what standardization means is that for each feature, we subtract the mean and we divide by the standard deviation. So we put it, we try to put it on the same scale. For example, wait. Here, wait, let me go back here. Just a second, let me get some water. I'm gonna be there in a jiffy because I really want to do this. I think I'm on a good track here. Moment. Okay, let's kill it now. No. Wait, let me get my pen. What's here interesting or unique or maybe a bit weird? It's this structure right here. So I have X train, this and this. What is happening here? I'm slicing through rows and columns. Basically, I'm taking all the rows, but in regards to columns, I'm only taking from column 1 onwards. I'm ignoring column 0. All right, I'm ignoring column 0, which is the bias term, which is always 1. I basically want to only scale the real features and leave the bias column alone. So if I print mean, and if I print standard deviation, why are they changing the what? What is the x print x train? So that's my x train. It's changing every time. No, it's not. Why is it right here? Operands could not be broadcast together, which shapes the. What? I messed something up. I did. I fucking did. Oh man, I hate it. Where have I stopped? Ah, here. Let's scale the inputs. Compute the. Okay, so the mean. If I print this again, train, will it work now? Have you seen this? Like a minute ago, these numbers were going crazy. We're getting crazy. What was happening there? What the fuck? What was happening there? So, what if I run it again? Okay, So X train, and it has three features here. The bias, I think, okay. The reason why we use this is because we are removing the bias. So we remove this and we are only looking at values 1 and 2. One of them is the petal length, and what's the other one? What's the other one? What's the petal width? So these are the only things I'm picking up. The petal length and the petal width, and I'm getting the mean of these values. If I print this out again, why is it, what kind of a number is this? And what about standard deviation? Print standard. This shouldn't be like this, because, let me just print this. Print X train. Because what it needs to do is it needs to sum all of these features, all of the values for the features, and then it divides it by the total length of the data set. So we have like what, 120 instances, right? So we have like 120 instances. Why do I get these numbers? It's an infinitely small number for some reason. What if I print tchdy again afterwards? Wait, tchdy, give me only first 10 elements. Same thing with you, brother. 0639, 063, what? Is it the same value? Have I changed anything here? Print divider. It's the exact same value. What? Shouldn't this change? Okay, it's a small value, most probably because this number is really small. Because I'm subtracting mean from my number. Yeah, this is a number. It's 10 on minus 18th. It's 0 point. I need to, in order to get this number, I need to move 18 fucking places to the left. It's 0.0000000000000 all the way to the left. It doesn't make sense. It doesn't make sense that this is the mean. Something is wrong here. Have I changed? No, I don't think I changed anything. Y train. X with bias. I just printed these guys out. There's no way this is the mean. There's no way this is the mean. There's no way that this is the mean. No fucking way. Something's broken here. Mhm. Could this be? Am I going crazy here? These values are can't be the mean. These values are extremely close to zero. They are practically zero. There's something wrong here. Wait, let me run all of this again above. What? Is it broken again? It is. How is it broken? What? These should be the values. These should be the values. There's something wrong with this script, man. There's something wrong with the script. The script is broken. Shit, I wanted to finish this whole example. Today I'm already one and a half hour in. Shit, I'm sorry guys, I need to end it here. I'm gonna continue from the next episode and